Hello all of you. So in the last class we have discussed about differentiation. In today's class we are going to discuss about integration. So if I quickly tell you, in the calculus part we have differentiation, correct, and we have integration. In differentiation we learned about how to split a function. It is similar to splitting. If y is a big rod, then the smallest piece will be called differentiation. Now all the small pieces, if you want to join and make it a rod again, make it a function again, then that is nothing but our integration. So integration is nothing but a joining. And we have let us say, first of all we need to learn types of integration. Indefinite integration, and second we are having definite integration. This particular integration where all the small pieces we are getting, so it is similar to summation, sigma. Summation when we want to add particular numbers, discrete values, 20 plus 25 plus 30 plus 35. So like that particular numbers you want to add, you will use summation of. Now integral or integration is the same family, but when you have a variables, when you have a function and you want to join the function, we will use integral of. So sigma also addition only, sir, joining, but we will add particular values. Integral also joining only, but we will add the variables, that is a function. Like in differentiation, your input will be a function, that is y is equal to f of x. Maybe algebra, maybe trigonometric, maybe any function where dependent variable is y and independent variable is x. And what is your output, sir? Like after you perform differentiation, what is the output that we are going to get? A derivative, that is the smallest piece, small change in y by small change in x. Whereas in integration, the reverse of this is happening, sir. Your input will be a derivative of a function, right? And your output, you will add all the small pieces and your output will be a function, that is y is equal to f of x. So differentiation and integration, they are exactly opposite to each other, sir. You have, let us say, example I am telling you, in differentiation you have y is equal to 2x plus 3. Then what is the derivative? Correct, it will be 2. Similarly, in integration it will be exactly reverse, sir. They will ask you find the integral of whatever you have got, that is 2. And after integrating, you will get this value as the final answer. Is that clear? This is reverse of differentiation. And how we are writing, sir? This is the integral symbol. This is how we write on paper to understand the input of the integration. What comes after the integral symbol is derivative of a function. What is it, sir? Derivative of a function. that is your input, the derivative of the function, which comes after the integral symbol. And the third part of this particular question is variable of integration. That means, for example, in this particular derivative, which alphabet, which variable I am joining? Let us say x. So x is the term that we have to join. If I put dt, that means t is the variable in this particular function. If I put dz, z is the variable in this derivative. Is that clear? If I put a dt, that means time. Dx, that means displacement. Dv, that means velocity. If the alphabet changes, the function also, the variable, we have to join different variable. Is that clear? Right. Let us go back. Let us come here. So what are the two types of integration we are having? One is indefinite integration and another one is definite integration. Indefinite integration and the next one is definite integration. Let us say now what is happening in indefinite integration? Very simple story, sir. We have integral of and f dash of x, that is derivative of certain function, into dx, which is variable of integration. After you perform this, equal to the answer, sir, f of x. The answer will be what, sir? F of x. Here without any limits, without any limits, and final answer, that is output, is a function. Output is what, sir? A function. That means it still there will be variables like 2x plus 3, 5x minus 6, or x square plus x cube plus x cube. Like that there will be function. And definite integration is similar to indefinite integration, sir. How we write on paper? Okay, so is equal to f of x, but there will be a lower limit as well as a upper limit. You have to integrate this value from a to b. That means let us say they are asking the value from 0 to 5 or 30 degrees to 90 degrees, like that, from this value to this value. Like even in summation also we will have the lower limit and the upper limit. No, whenever you are having lower limit, upper limit, you have to integrate, start integrating from this value to this value. So lower limit is a, upper limit is b. Always what we have to do, sir? Firstly substitute the upper limit, then subtract the lower limit. This is the process. First we have to substitute the lower limit, then we have to substitute the upper limit. Couple of examples if I teach you, you will understand it better. Okay, so currently understand, indefinite is there, definite is there. Indefinite means without any limits. Indefinite means without any limits. Output is a function. And what do you mean by definite integration? Within limits. And output is a value. Value means a number, like answer is 5 or answer is 8. Let us say I am asking the length of this pen, and when the pen is kept, let us say at x is equal to 0 and it is ending at x is equal to 8. So you will substitute 0 to 8 and you will get a final answer 8 minus 0, that is 8. So the length of the pen will come as a value. So when you have proper limits, we will do definite integration. When we don't have any limits, we want a variable as my answer, then we will do indefinite integration. Is that clear? So in the next slide we will do couple of more examples, then we will go with the formulas. So as I already told you, differentiation and integration both are exactly opposite to each other, sir. Even when they have made, even the formulas also, whenever they are prepared, so they have done in such a way that exactly opposite. Like here when I give this as my input, then I should get this as my output. So the integration concept is made in such a manner. And already I have informed you, if you learn differentiation properly, then integration would become an add-on topic, which is very easy it will become. Like for example, there is a question, y is equal to x power n. Then what is the derivative? N into x power n minus 1. We have discussed in the last class. So step by step if I write, what I am doing, sir? I am multiplying the power. Next, I am subtracting 1 from the power. So I am doing two things. Multiply the power, subtract 1 from the power. Then whatever this value is there, that is coming as an input for integration. That is coming as an input for integration. So what is happening now? Let us see. Integral of x power n dx. Let us say the question is in the form of x power n dx. Now the second step should be first step here, and the first step should be second step here in the exactly opposite sense. Then differentiation is of integration we can satisfy. So what we will do? Subtract 1 from the power. So reverse of that would be add 1 to the power. Next, multiply the power. Reverse of this, sir? Correct. Divide the power. So in such a manner, like for example, there is a question, y is equal to x cube. Then what is dy by dx? Multiply the power 3x square. Now this is my input of integration. Integral 3x square is the input, and which variable we have to join? X variable. So dx, integral derivative variable of integration, so is equal to, so we know 3 is a constant will come outside. It is in the form of x power n. X power n means add 1 to the power, that is n plus 1, by divide the power by n plus 1. So x power 2 plus 1 divided by 2 plus 1, if I do, it is becoming x cube by 3. So you can see the final answer, integration of this whole thing is coming as x cube, which is exactly the reverse of differentiation. So all formulas are prepared in such a manner, exactly opposite. Like if I give you example, derivative of log x is 1 by x. So integral of 1 by x is log x. Correct? Derivative of e power x is e power x. So integral also it will be same, e power x. Derivative of sin x is cos x. So what is the integral of cos x? Sin x. So exactly opposite. Is that clear? Derivative of x is 1. So reverse. Integral of 1 will be x. So let us go with the formulas. The next slide. So in this slide, what I'll do, I'll try to write all the formulas, because I hope you understood how these have been originated. So next slide, let us go and learn with the examples. So please start writing, sir. So integral x power n dx is equal to x power n plus 1 by n plus 1. Add 1 to the power and divide the power, plus c, where n is not equal to minus 1. Why n is not equal to minus 1? Because when n equals minus 1, denominator will become 0, it will become an undefined value. Clear? And why this plus c is coming, I'll explain you in the next slide. Currently please copy, sir. Next, So what is the formula when x is equal to -1? There must be another formula, because we should not use this formula for that. Remaining all other cases, -2, -3, +2, +3, 2/3, 5/3, anything is the power, you can do this, but only except for -1. So for -1, the formula is very simple, sir. I hope already you know. Can you guess? Correct. Differentiation of log x is 1/x. So integration of 1/x would be log x. Good. Plus c we have to write, sir. Why we will write, I'll let you know. Next, integral dx. So if you see here, integral symbol is there, variable of integration is there. In between the input is missing. Whatever the input is there, that is missing here. So if nothing is there means 1 is there. And 1 can be written as, in terms of the variable, x power 0. So something power n is nothing but add 1 to the power and divide the power. So that is x. So differentiation of x is 1. So integration of 1 would be x. So why I am writing plus c, I will let you know, sir. Next, integral u plus v dx. Expand the bracket, integral u dx plus integral v dx. Integral sin x dx is equal to minus cos x. Why minus cos x? Because derivative of cos x is minus sin x. So integral of sin x is minus cos x. Okay? Yes. Next. Integral of cos x would be sin x plus c. That is as usual. Integral of secant square x tan x. Why? Because derivative of tan x is secant square x. Integral of e power x is still e power x. Okay, so these are the formulas that we frequently use in physics part of integration. Is that clear? There are, in mathematics this topic is little more depth. Why? Because for math students is a separate chapter, but in physics the basic idea is more than enough. And if you observe carefully, u into v, u by v, that is multiplication and division rule, we have not discussed in integration, because for physics point of view that much deep integration we don't require. Addition subtraction is more than sufficient. Is that clear? And one more, whenever a constant is multiplied with a function, so as usual, sir, keep the constant outside and integrate the function. Okay, constant, any constant is multiplied by a variable, keep the constant outside, integrate the function separately. Is that clear? And everywhere if you see after performing integration, I have put plus c, plus c. What is the need of that plus c also we will discuss in the next slide. I hope you have copied this one, sir. Yes, right. Next. So what is the story behind plus c? Let us say there is a question, x square plus 25. Another question, x square minus 720. Another question, x square plus 12.58, some random number. So what is the derivative of these? You can observe these are functions, sir. So input is a function means output must be derivative. So what is the derivative of these functions? X square derivative, multiply the power, subtract 1 from the power, 2x, plus constant derivative 0. Here x square derivative is 2x, constant derivative is 0. Here x square derivative is 2x, constant derivative is 0. Now, when you come to integration, you will get only integral 2x into dx. You will get only what, sir? Integral 2x dx. And when you integrate it, keep the constant outside 2 and x power 1. So x power 1 is there, means x power 1 plus 1 by 1 plus 1. X square by 2. It is coming as x square. So when you perform integration, sir, whatever the change happened to the variables, the alphabets, that we can retrieve back, because the formulas are made in such a way that if from x square you differentiate to x, means from 2x I will integrate to x square. The variable can be retrieved easily, but whereas the constants, when you have performed differentiation, the derivative of the constant became 0. Now 2x plus 0, when I do integration, I can retrieve the variable, but I can't retrieve the constant. I don't know whether this question belongs to plus 25 or plus 720 or plus 12.5, because output of all the three derivatives is 2x only. Is that clear? So just because the constant died in differentiation, it became 0. Correct, sir? So we can't retrieve that information back. So that is why what we will do, just to pay some respect to the constant which died in the differentiation, we will write plus c. Now that c can be 25, that c can be minus 720, that c can be 12.5, that c can be 0 also. We don't know, because maybe there was a constant. When this question came to us, maybe there was a constant which might have become 0 after differentiation. We can't retrieve the information, so we are writing what, sir? Plus c. Got it? So everywhere we will write plus c, and these are the formulas for definite integration as well as indefinite integration. But when it comes to indefinite integration, we have to put limits. There will be lower limit as well as upper limit in definite integration. First of all, we have to substitute upper limit, then we will substitute lower limit. So after discussing few examples of indefinite, we will go to definite integration as well. Okay. Next, please copy the question and try to solve the answer, sir. Right, let us go to the first question, sir. So simple question, integral x square. So it resembles with the formula integral x power n dx is equal to x power n plus 1 by n plus 1. That is, add 1 to the power and divide the power. Okay, so n is 2, so we will write 2 plus 1 by 2 plus 1, which is x cube by 3. Is that clear? Add 1 to the power and divide the power. Now it is in the form of u plus v. So open the bracket, write separately integral 2x cube dx plus integral 3x dx. Okay. Now 2 is a constant, keep outside. x cube. So add 1 to the power, divide the power, x power 4 by 4 plus 3 is a constant, keep outside, x power 1. So 1 plus 1 by 1 plus 1. In the end, after everything you write, you add 1 plus c. Like no need write 1 plus c here also, write 1 plus c here also, no need. So 1 constant at the end of the equation is enough. I hope you understood. Right, next. Integral t square minus t dt. So in this question, x was the variable. So we have added the x. In this question, who is the variable? T is the variable. So we have to integrate the t. So t power 2 is there. So 2 plus 1 by 2 plus 1 minus minus. T power 1 is there, sir. So 1 plus 1 by 1 plus 1. In the end, we will write plus c. Understood? I try to reduce one step. Directly in the mind, I have calculated integral u dt, v dt. Then the direct last step I have put here. I hope you understood. Next, in this question, v is the variable. Like this is displacement, this is time, this is velocity, like that. So we are integrating velocity. Again, now let us say this is a definite integration. They have given limits from 0 to 2. They are asking us to find integration from where to where, sir? From 0 to 2. First open the bracket, sir. Integral 3v square dv from 0 to 2 plus integral 2v dv from 0 to 2. Correct? Just open the bracket. Now 3 is a constant, keep outside. V square, what is the integration of v square? V power 1 plus 1, v cube by 3 from 0 to 2 plus 2 outside, v dv integration, v square by 2, power 1 is there, sir, 1 plus 1 by 1 plus 1 from 0 to 2. Now I can cancel 3 and 3, 2 and 2, okay. So it became v cube plus v square. So always what we have to do, sir, first substitute upper limit, then substitute lower limit. So v cube. So instead of v, the variable, we will put a lower limit minus upper limit. Okay. So that is upper limit minus lower limit plus again v square minus 0. Who is v? Upper limit is 2. So like this, first upper limit minus lower limit, again upper limit minus lower limit, whatever the function is there. So what will happen, sir, here? 2 cube will become 8 and 2 square will become 4. So the answer for the question will be 12. Okay, when you integrate 3v square plus 2v from 0 to 2, final answer will be 12. That means I have already told you, in definite integration, excuse me, definite integration, we will have limits. Once we integrate, we have to put upper limit minus lower limit, and your final output will be a value, number. Is that clear? Let us go with some more examples. If you want to copy, please copy, sir. Pause it and copy. So let us say integral cos x dx from 0 to 90 degrees, let us say, sir. This is the question. So first let us remember the formulas. What is the integration of cos x? Sin x, not minus sin x, plus sin x. It is reverse of differentiation. So the integration of cos x is plus sin x. You can check the formula sheet also. And one more thing, sir, here you might get a doubt that, sir, you forgot to put plus c at the end. Why in the above, in indefinite integration you have added plus c, but when it comes to definite integration you have skipped writing plus c. Why I have skipped? Let me explain you, sir. Now let us say even if I write plus c also, when I put upper limit, first put upper limit, sir, sin 90 minus, we have to put lower limit, sine 0. So in definite integration, there is no need to write plus c, because whatever was the constant, when you put upper limit minus lower limit, c minus c, it is anyway going to be 0. It is anyway going to be 0, because in the upper limit also the same constant, in lower limit also the same constant will come, and this minus this will become 0. So whenever you are writing definite integration, you can consciously skip writing plus c. But when you are trying to do indefinite integration, that is without limits, consciously please write a plus c extra. I hope you understood. Correct. So no need to write plus c in the definite integration. So now tell me, sir, sine 90 degrees, pi by 2 is 90 degrees. So sine 90 is 1 minus sine 0 is 0. Is that clear? Okay, next question. Integral root x plus 1 by root x whole square, let us say. Like this they have given. Looks like very terrific question. No. What we have to do is in the form of a plus b whole square. Expand the equation. So a square, that is root x square, plus b square, that is 1 by root x square, plus 2ab. Correct? Now you can perform the integration, sir. So 2ab la a and b will cancel out. Root x square, that is x dx, plus 1 by root x square, that is 1 by x dx, plus 2 dx. Okay. So x power 1. What is the integration of x power 1? Correct. X square by 2. Next, 1 by x. What is the integration of 1 by x? Good. Log x plus constant is outside, sir. Integral dx, that is integration is there, variable of integration is there. So nothing is there in between, means 1 is there. So what is the integration of 1? X. Integral dx means x. Integral dt, t. Integral dz, z, like that. So here it will be plus 2 into x, and since it is indefinite integration, we will write plus c at the end, which will be the answer for this question. Is it clear? Please copy quickly, sir. Let us go with the next concept. We have a question in such a manner, sir. Let us say integral sine 3x. We know integration of sin x is minus cos x, but we have function inside and another function. Chain rule we have done in differentiation, like that. So same story, sir. Here whatever we have done in chain rule, same story. Assume inner function as a new variable t. So t is equal to, who is the inner function? 3x. Then differentiate this, sir. dt by dx. Independent variable is x, dependent variable is t. So dt by dx is differentiation. 3 outside, derivative of x is 1. Cross multiply, sir, because we have to eliminate x also. So cross multiply. So dx is equal to dt by 3. So now I eliminated 3x in terms of t. Sin 3x can be written as t. Similarly, dx can be written as dt by 3. Because 3 is nothing but derivative of inner function. if t is equal to 3x is inner function, okay, then it is a derivative of inner function. So constant keep outside, sir. Sin t dt, what is the derivative of, sorry, integral of sin t minus cos t. And t you have assumed, sir, you have assumed the t. So what we can write here? As per the given question, what is t? (3x). So minus 1 by 3 cos 3x is the answer, and plus c we will write at the end. Is that clear? So minus 1 by 3 cos 3x. If you observe carefully, sine of something integration is minus cos of something, and inner function t is equal to 3x, derivative is 3. Did we divide in the answer or multiply in the answer, sir? We have divided in the answer. In differentiation chain rule, we multiply the derivative of inner function, sir. In integration of chain rule, we divide the derivative of inner function. Okay, so whenever, shortcut, what is the shortcut, sir? Whenever there is outer function as well as inner function, okay, sine of something, we integrated to sin t to cos t. Outer function we are integrating. So integrate the outer function, and whatever the inner function is there, sir, t is equal to 3x, that we had to differentiate and divide the value. So we have to differentiate the inner function, and we have to divide that value. D by dx means derivative of inner function at the denominator. This is a shortcut we will do. That means integrate outer function. So sine of something is minus cos of something, that is sin t cos t, divided by inner function 3x. What is the derivative of 3x? 3 into 1. Is that clear? Sine of something integration is minus cos of something, 3x derivative is 3. So if you observe carefully, that is the answer you have got. So what is the shortcut, sir? Integrate the outer function, divide the derivative of inner function. So that gives us couple of more formulas, sir. Integral sin nx, where n is that constant that we were talking about. So integrate the outer function, sir, minus cos nx divided by derivative of nx is how much, sir? N. So this becomes a formula now. In oscillations and waves chapter, we will use this particular integration exclusively multiple times. And integral cos nx. What is integration of cos nx, sir? Integration of something, outer function, cos of something, sir, sine of something, divided by derivative of inner function. Nx derivative is what, sir? N. Okay, right. Next, one more formula, sir. Integral 1 by ax plus b. 1 by ax plus b. So inner function is t, sir. So it will become integral 1 by t, and dt is how much? Dx is how much, sir? Dt by a. So instead of dx, what we will write? Dt divided by a. So constant is a, sir, keep it outside. So 1 by t dt, 1 by x dx is log x, like that 1 by t dt is log t. And t you have assumed, sir, as per the question, what is t? Ax plus b. So 1 by a into log ax plus b. Is that clear? So same story, 1 by something integration is log of something, and once you integrated the outer function, divide the derivative of inner function, sir. Divided by derivative of ax plus b is how much? A. So if you observe carefully, that is the answer we have got. Integrate the outer function, divide the derivative of inner function. 1 by x derivative is log x. Is that clear? So these formulas we will use frequently again and again. Okay. Now let us do some more examples. This is an example of definite integration. Yes. Again an example of indefinite integration. Next. Again an example of indefinite integration. Let us solve this. So first of all, expand the equations are integral 3 outside x square dx plus integral 2x dx from where to where? 2 to 5. Okay. Now 3 is a constant, it will come out of the integrations are 3 is outside, x square 2 plus 1 by 2 plus 1 from 2 to 5 plus 2x, 2 outsides are x is x square by 2 power 1 plus 1 by 1 plus 1 x square by 2 from 2 to 5. So x cube. So x cube means upper limit is 5, lower limit is 2. So x, instead of x you have to put upper limit, that is 5 cube minus 2 cube plus again x square and lower limit. So what is the upper limit here, sir? 5. And what is the lower limit? 2. So calculate the value, sir. 125 minus 8 plus 25 minus 4. Is that clear? So this is how we solve the question upper limit minus lower limit. Upper limit minus lower limit. Similarly, 1 by something, that is in the form of chain rule. 1 by something integration is what? Log of something. Integrate the outer function and divide the derivative of inner function. 2x plus 3 derivative is 2. Now we have to integrate it from where to where? 0 to 5. So first substitute 5, then substitute 2. Okay. So I hope this is clear now, sir. 125 plus 25, 150 minus 12. That is the answer. Okay, right. Next, so first put upper limit. 1 by 2 is a constant, keep outside. When you put upper limit, log 2x plus 3 minus, again lower limit, log 2x plus 3. So upper limit is 5. Instead of x we have to put 5. Lower limit is 0. So log of 5 is a 10 plus 3, 13 minus the 2 into 0, 0. It will become log 3. So I hope we know that log a minus log b is log a by b. So that is 13 by 3 will be the answer for this question. Okay. Next, 3t minus 5. Same story, sir. Open the bracket 3t dt minus 5 dt. So 3 is a constant, keep outside, t power 1. So t square by 2 minus 5 outside. Integral dt is t. Integral dx is x. Integral dz is z, because integration of 1 will be the alphabet. Here which alphabet? T. So we have to put t. If the variable of integration is x, integral dx will become x. So limits from minus 3 to plus 5. Minus 3 to plus 5. Minus 3 to plus 5. So first substitute the upper limit, then substitute the lower limit. Upper limit minus lower limit will be the answer for this question. Is that clear? So differentiation is very important, integration is also important. But don't consider integration as a fresh topic. Try to learn differentiation very well and think integration is just the opposite of it. It is an add-on of differentiation. Is that clear? So I hope the lecture is clear. So that's it for now. Thank you.